The world's first large-scale hydrogen engine has been tested in Spain. The giant engine, powered entirely by pure hydrogen, has successfully generated electricity for Spain's national grid in what its manufacturer describes as the world's first for large-scale power generation. So, this raises the question, is hydrogen the new oil? Hydrogen is becoming a serious industrial fuel, not a replacement for oil across the board. Think of it less as new oil and more as clean coal replacement for industry. So why are the government and companies investing hundreds of billions into hydrogen? Japan has successfully ran the world's first hydrogen fuel main engine for a large commercial vessel, achieving over 95% hydrogen under full load with stable operation and significant greenhouse gas reductions. Spain itself is becoming a serious hydrogen hub. BP and Iberdrola are commissioning what will be Spain's largest green hydrogen facility, with testing beginning in May 2026. But hydrogen alone won't replace coal and gas. The picture is more like renewables plus nuclear replaces coal and gas in electricity. Hydrogen replaces coal and gas in heavy industry and transport. Batteries and efficiently reduce demand everywhere else. Hydrogen is destined to replace coal in steel factories, but for now it should stay away from coal power plants. The steel industry is responsible for roughly 7% to 9% of all global greenhouse gas emissions, and coal is primarily the culprit. In a traditional blast furnace, coal isn't just burned for heat. It acts as a chemical reducing agent to rip oxygen atoms away from iron ore so it can become pure iron. If you pull coal out of a steel plant, the whole chemical process stops working. Hydrogen is the only clean element that can do this exact same chemical job, but when it comes to the electric grid, using hydrogen to replace coal power is a thermodynamic nightmare. Think about the loop required to make this happen. You generate clean electricity, then you use that electricity to split water and make hydrogen gas. Then you compress, transport and store that hydrogen. Then you burn that hydrogen in a power plant to make electricity again. Because the laws of physics, you lose energy at every single step. By the time you turn that hydrogen back into electricity, you have lost more than 60% of the original clean energy you started with. So ultimately, hydrogen won't replace coal everywhere. But with the Ukraine war made energy security and domestic industrial fuel production a top priority, especially in Europe and Japan, hydrogen is increasingly being explored as a way to solve one of the biggest challenges facing renewable energy systems. Rasmus Teer, head of sustainable fuels at Wärtsilä, says hydrogen-fueled engines could perform the same. That is, balancing function without carbon emission if the hydrogen is producing using renewable electricity. Teer explains,
the long-term vision or the role of this product is for future energy systems that are 100% renewable, meaning that you have a base of renewables, wind and solar, but these are intermittent forms of energy, so you need something to balance it, and that's where this engine comes in, to balance the renewables of wind and solar, providing firming to the grid and long duration balancing. Operating then on hydrogen, you can create energy systems that are 100% renewable.
However, the hydrogen is being trucked to the facility, and the company admits large-scale deployment will likely require entirely new pipelines and infrastructure. In fact, green hydrogen costs 3 to 5 times more than hydrogen made from fossil fuels today. The economics only works with heavy subsidies right now. It's also hard to store and transport. Hydrogen is the smallest molecule in existence. It leaks through almost everything, makes metal brittle over time, and has to be stored either at extremely high pressure or extremely low temperatures. The infrastructure required is enormous and costly. It's explosive and tricky to handle. Supporters of hydrogen argue it could become an important partner to renewable energy rather than a replacement for it. The idea is to store renewable electricity in the form of hydrogen when there is surplus generation, then use it later when demand rises or renewable output falls.